Good morning, everyone. Today we're going to talk about finding the volume of solids with known cross-sections. So we've been talking about finding the volume with a disk method and a washer method. And all of those dealt with some type of rotation. You're revolving something. And we're able to find the volume of that disk or of that washer because we know the area of the formula, the area of a circle is pi r squared. And that kind of helped us build that solid. Now we're going to talk about a cross-section. And I put up some videos before this one as an introduction so you can kind of start visualizing what it's going to look like. And there's some formulas that we're going to need to know. Namely, rectangle. Well, we know the area of a rectangle is base times height. The square, the area is the base to the second power. A semicircle is pi over 8 base squared. Equilateral triangle, rad 3 over 4 base squared. An isosceles right triangle with one of the sides being down is 1/2 base squared. An isosceles triangle with hypotenuse down is 1/4 base squared. And so these formulas right here, there's 6 of them. These formulas right here we're going to need to know. And the good thing is we're going to have them in front of us so we won't have to memorize them, but they're not that bad. We should know a lot of it. Now, one thing I do want to point out that all of these formulas have a base. And all these formulas, we need to figure out the base of each figure. The base of a square, the equilateral triangle, a semicircle. I'm going to focus a lot on figuring out the base of the shape. And then we'll use the formula. So what do we do to find the volume? If the cross-section with an area of a sub x taken perpendicular to the x-axis is given as the integral of the area from a to b. This is an area. If the cross-section a sub y or area of ay taken perpendicular to the y-axis, the volume is equal to the integral of the area. So note that we have to make for ourselves. If the cross-section is perpendicular to the x-axis, we will be in x's. If we're taking perpendicular to the y-axis, we're going to be in the y. Each problem will tell you where we're going to be perpendicular, so we'll be able to decide if we're going to be in dx or dy. And again, it's always going to be about that base, finding the base of the solid. So here goes number 1. Find the volume of the solid. The region is bounded by that f of x and g of x, and x equals 0. And so it's drawn right there already. That's the f of x and that's the g of x. And x equals 0 just happens to be the y-axis, so we're talking about this shape right there. And we're told that the cross-sections are perpendicular to the x-axis and they are squares. So the visualization that we need to look at, this is the base of the square and it's popping up. It's popping up. I'll put a video and graph this one and show you the solid that is created. So let me see here. If I'm told it's perpendicular to the x-axis, that tells me I'm going to be in dx. I'm also told that they are squares. So because it is a square, the area of a square is the base to the second power. So I need to know the base. And the base comes from here. The base is the distance from here to here. The base is this right here. I need to figure out the top minus the bottom. Notice how none of that has changed when we did the area between two curves, top minus bottom, or when sometimes we had a volume rotation, we had to do top minus bottom. So the base of this solid, I get the top function, and I'm going to subtract the bottom function. So in this case, the top function is 1 minus x over 2. The bottom function is negative 1 plus x over 2. And so when I subtract, so if I distribute that, that gives me 1, that's 2. If I distribute that, that gives me a negative there, a minus. And I guess I have another minus there, so that's minus x. Verify that, make sure you agree. So that's the base. So let me come this way now. So when we ask you to find the volume, you need to integrate the area function. I probably won't be writing this too often, but volume is equal to the integral of the area. And in this case, the area is a square, which is the base to the second power dx. That is the area of this square, base square. The limits, I need to look at the x's because I'm in dx. So I have my graph there, and in my x's, I'm going from 0 to 2. That is the setup to find the volume of this solid. I invite you to pause, do a little bit of algebra. I don't want to do all this baby work for you. We are all experts at this now. Integrate, top minus bottom, and you should get 8 over 3. Let me set up the next one. So again, we're given this graph here. Same equation, by the way, as the first example. But now the cross sections are going to be perpendicular to the x-axis and are equilateral triangles. So keep that in mind. You got to deal with equilateral triangles. Different formula. I'm still dx. But now I have an equilateral triangle. The base from the first one, from the other example, is that the volume is equal to the integral of the area. That's out of focus, or is it me? So when we ask you to find the volume, I'm going to integrate the area of an equilateral triangle, which is rad 3 over 4, the base squared dx. Equilateral triangle, rad 3 over 4, base squared. And the limits again, I'm going on x's. The x's are going from 0 to 2. So I will invite you to integrate that yourself. Some things we should know. This rad 3 over 4 is kind of in my way. I don't want to integrate that. I'm going to take it out. And then I will integrate what I have left, which I'm going to square that. Ooh, 0 to 2. And I'll invite you to do the work. Pause. Do a little bit of algebra. And you should get 2 rad 3 over 2. Biggest thing here is the volume is the integral of the area. The area of an equilateral triangle is rad 3 over 4 base squared. Okay, let's try another one. The volume of solid whose base is the circle there and whose cross sections are rectangles whose height is always 3 times the base and whose sides lie perpendicular to the x-axis on the base of the circle. Okay, a lot of things happening here. Let me start by writing some things here. We're talking about a rectangle. And the area of a rectangle, I need to know the base, and I need to multiply that by the height. That's the formula, base times height. So the base has something to do with this circle. And if if I would have thought about it, I would have graphed them already, but let's see if we can kind of do a quick little sketch here. X squared, y squared, center 0, 0, radius of 2. Nothing too fancy. And I'm not even going to try to cheat. Well, that was louder. All right, so here we go. 2, 2, negative 2, negative 2. So there's my circle. The base is perpendicular to the x-axis. The base is from here to here, perpendicular to the x-axis. That right there is going to be my base. So to figure out the base, I need to get the top function and the bottom function. And so the top function is the distance from here to here. And the bottom function is the distance from there to here. And in order to find those distances, I need to get my equation of the circle and solve for the y. So let me do that. So I have my circle. And if I ask you to solve for the y, subtracted the x squared, I'm going to take the square root. I hope you can see that. I'm going to take the square root, I get plus and minus square root of 4 minus x squared. That plus and minus comes in handy. We need that. We need to know that you're taking the square root of an equation, you get that plus or minus. So the distance from here to here is y equal the positive square root of 4 minus x squared. And from here to here is y equal to the negative 4 minus x squared. So you have the positive one going up and the negative one going down. And so when we ask you to find the base, I got to subtract that one minus that one. So the base is the top the square root of 4 minus x squared minus the bottom, which is a negative, be careful with that. And when I subtract, yes, that becomes a positive. So you have one of those plus another one of those, which means the base would be 2 of those. Top minus the bottom, that becomes a plus, so there's 2 of them. So that's my base. Okay. Remember, the biggest thing is the base. Let me go back here to my formula. The area of this rectangle is the base times the height. Now let me read the problem again. They did tell me something about the height. The height is always 3 times the base. So the height is 3 times that base. The height would be 6 square root of 4 minus x squared. So calculating the area is 12, because I can multiply. As a matter of fact, when I multiply the same radical, the radical just kind of goes away. I'm left with that. So that is the area of that shape. So volume equal to the integral of that area I will take out that 12. When I integrate, I'm in x's, so let's look at the x's. The x's are going from -2 to 2. So again, I invite you to pause, do a little bit of work, and then we'll come back. Oh wait, don't pause yet. Notes. Yeah, I could take out that 12. It's going to help me. But I want you to see the shape of my circle here. We're actually integrating from -2 to 2. Because that's the x's. Because of symmetry, I could actually integrate from 0 to 2. If I integrate from 0 to 2, if you look at my drawing, that's half of it. And so if I change my integral from 0 to 2 and only integrate this part, I can multiply that by 2. Now, you don't have to do that. I'm doing it because then that way my limits, at least the bottom limit, will be 0. And then when I do the top minus bottom, when I integrate that, it should simplify my life a little bit. Okay? But you don't have to. You could always go from -2 to 2. Okay, so now pause and do the work. So, all right, so that's a 24. I'm taking out that 12. And I integrate that. And so my answer comes out to be 128. Okay, homework on this one. Please set up and do problem number 14 or example number 14. Read carefully. Some are perpendicular to the x, some are perpendicular to the y. Read carefully. Also do number 15. And on this one, because we're calculator, set it up. Make sure I can see the setup, and then we'll integrate. Have fun.